Why were
I'm not
we,
Pablo Missouri.
when we first had the, we first thought it was right here, why were we looking for this angle and not this angle?
It's the same.
Oh, it's the same,
They're,
okay.
these are parallel to each other, and so two parallel lines cut by transverse, alternate interior angles are congruent.
Okay, good to know. I was wondering about that.
I do
Have you
not
studied
grasp,
for the GRE? Come on.
Absolutely not.
I do not grasp anything you just said.
If I have any two parallel lines,
Right,
and it's cut by another line,
right.
these are called alternate interior angles. They are the same value.
Mhm.
That's, so what I said is two parallel lines cut by transverse, alternate interior angles are congruent.
Yeah. Okay, thanks for breaking it down.
Yep.
I remember
This-
learning that in
that is-
eighth grade.
Right.
And then properly, that's in Euclidean geometry.
Are you secretly a math person, but you just like throw shade at math people because you're in denial about it?
That's the question asked ever in the class.
Like I've always held that question, I just feel like today's the day.
What was the second part? My secretly a math person, but
But throw shade at math people, cause you always talk about the math people this and the,
yeah.
what, right? So I just feel like
All
you
the
might
time.
secretly be a math person at heart and either in denial or like guilty or regretful or something. I think you love physics, but I think that your first love feels like math.
It actually would have been.
It's valid.
Yeah,
Best question I've ever asked.
Thanks, Bill.
childhood scars. No, I really enjoy math, but there are certain things that, yes, I will make fun of them, because they haven't told us how to divide things by zero properly yet. What's up with it? What do they do all day?
Yeah, it's ridiculous.
Come up with whatever that thing with the squares and the brackets that we were doing for a while. That's what they're doing all day.
There are a couple of problems which if they can solve, they get $1 million, but is anyone solving them? I don't think so. Right. Right. This is a far more complicated problem. Asking 152 students to go through and come up with this level of answer would be cruel. I'm not saying I haven't done something like that, but it would be cruel. What is definitely reasonable for you to be able to do is draw the phasor diagram for it. So when you're given something like this, where there's obviously in a series circuit, the current's the same for everything, I can draw that phasor down, and that's my starting point. If it's a parallel, like we did a RC parallel, you start out with voltage, draw that down, because that's common for everything, and we're good to go. But with something like this, where do you start? So, where you start is, if I change the problem around to, let's think of in terms of DC circuit. If this were the circuit and I said, what is the equivalent resistance, what is the first thing that you would do? If this were R1, R2, and R3, how would you find, what's the first thing you do to find the equivalent resistance?
Put them in series,
What two are in series?
R2 and well, I'd put the ones that are in parallel in series.
Oh, okay. All right, so you start with the parallel ones.
Yeah.
Find their equivalent resistance.
Yeah.
And find their equivalent resistance.
In terms of the phasor, you start with the parallel ones, then here. Whatever you would do first to find the equivalent resistance, you do the exact same thing here in terms of drawing the phasor. So what phasor is common to both of these?
Voltage?
Yes. Without the question mark this time.
Yeah, voltage.
Yeah, there we go.
I have a problem.
And that is the starting point. And I'm just gonna draw it to the right because that's just simple.
That's your new for today.
So that's VR, which is equal to VL. And if we were going through this and doing the full blown, trying to get to this level, I would probably just label it as VRL, as just a shorthand for it's the same voltage for both. Now I have that, I can get at least two current phasors down. Somebody tell me one of the current phasors I can get down.
Are we going back to Eli the Iceman for this?
Yeah.
Okay, Yep.
So,
or one of them.
for our inductor, voltage leads,
Therefore,
the current, so current is going to be down.
there's I sub L.
And then current leads the voltage, so the other one is going to be straight up for the,
There's no capacitor yet.
oh, I see, thank you. That's getting ahead of us. I have no idea how you do this.
So just as we have epsilon sub naught, VR, VL, VC, I power supply, IR, IL, IC. Those are the phasors we need to have drawn here. We have those two done, and we have I sub L done. And I sub R is the next one to do. What's the relationship between I sub R and V sub R?
Looking at this
Shouldn't-
formula there.
Should it be equal or no?
What's equal?
Should it be in the same direction?
Yeah. The phase between IR and VR is, they are in phase or zero. I sub R. Yeah, there's no Eli the Iceman for the resistance. The resistance, they're just in the same direction.
They're always gonna be in the same direction?
Yes.
Okay.
All right, so I've got IR and IL here. The direction of, so the next thing is I have two currents. I have this current. So if you imagine currents flowing around like this and then splitting, what can you tell me about the relationship of IC with IL and IR?
It's greater than that of IL or IR, because it splits when it gets over here.
Oh, okay.
And by a similar kind of logic, more of the current should go towards the inductor, because it doesn't want to be on the resistor, so IL should be bigger than IR.
Not necessarily. It depends on the values of the resistance and the inductance. That which one would get more would depend upon the relationship between R and the inductive reactance.
Oh, no, okay,
But we don't have to take it that far.
okay.
But the fact that IC splits, IC is equal to IL plus IR. Whatever the sum of these two are is the sum of this, is equal to that. And so if I add them together, that's I sub C. And now that I have I sub C down, we got that, and we have I sub C. Now I know where I sub C is. I can find V sub C.
Current leads the voltage, so, oh, is it going to be in the third quadrant? Like,
Wait, which one leads? You said current leads voltage, okay.
yes. So it's going to be, yeah, that direction.
And that's a 90-degree angle there. It's supposed to be. Something's off.
Current leads.
So for, that's VL, that leads current. So current's there, add those. Voltages, okay. I think like it's backwards from what I was originally expecting, so either I changed the problem unknowingly or there's a Carol's error in here somewhere. All right, and then finally, that would be BC. Epsilon's of knots, the last phasor. Well, if I'm going from here to here, that's the voltage across my phasor, or across the power supply, or going the other way, it's voltage across here and that. In other words, the sum of these two will get me epsilons of knot.
For the current of the power, actually go ahead with what you were gonna draw.
So now adding my two V's here. That's epsilons of 0 right there. And then IPS, I don't have, the current for the power supply, I don't have marked it yet. What's the current for the power supply?
Is it going to be the same as the current for the capacitor, because they're in series?
Absolutely. And done. But as you probably have heard, class is over.
I just have a quick question about how you found the sum, because it looks like you drew this line kind of out at an angle, and I don't really understand.
This one?
Yeah,
If I'm adding vectors. So if I add that vector and that vector together, I would move this over, so it's in the same points in the same direction, same magnitude. And that's the sum. Or
right.
with two of them, it's known as the parallelogram method. You basically draw a parallelogram and it's the diagonal.
Got it, okay, thank you.
That was a good question, I was also wondering that, but.
Yeah, I was like, shouldn't it, yeah, but like.
Yeah, in my head, I'm like, I want it to go straight down, but then the bottom vector is the same.
Right.
So recognize how, because this is not a right triangle here, to actually solve this, you're gonna be using law of cosines. It's loads of fun. And at that point, you're thinking, there's gotta be a better way, and,
Yeah, there's not.
well, it depends on your comfort level. You can turn this into the exact same type of analysis we did for the DC, if you don't mind imaginary numbers. J is the same as
I think
-1.
it's time for us to go.
I'm missing imaginary numbers.
You do?
Not really.
Negative J x of C, this would be positive J x of L, and this is R. And so, if you think of this as a component with that resistance, component with that resistance, and that resistance, get the equivalent resistance. Good time to tag by all, you can bring in imaginary numbers. Or complex numbers.
I'd like it to be known that I have officially filled out my notebook. This is the first class that I've done for, it's probably high school, so I gotta go get a new notebook.
I made that mistake last semester, I ran out of space, so this semester I got the like 3-subject notebook, and I'm in the 3rd subject of the notebook.
With just.
It's a race to
Just
the
this
end.
class?
Yeah,
That's wild.
That's, yeah.
yes.
Oh. I couldn't remember on Wednesday or Pam's got fax. You're still here. Most people are.